Okay, if I'm really tired or I don't make sense, I'm sorry. Long weekend, a long 2 weekends, and then horribly long week in between 2 long weekends. So, ouch. Comparing fractions. So I would remind the kids that they're going to be using comparison symbols, such as less than, which we're going to bring back that 1 dot is less than 2. Greater than is another comparison symbol. 2 dots are greater than 1 dot, and equal is also a great comparison symbol to use. So, comparison symbols. It wouldn't even hurt them to write comparison, comparison, symbols. What are symbols? I might ask. Pictures, that's right. How do I remember which is which? They might say, oh, the alligator eats the bigger one. Okay, well, that's good as far as the placement, but when you have to read left to right in a word problem, it doesn't help them. So, or it doesn't help many, I've noticed. So the dots really seems to help. So how do you know which fractional amount is more or less than the other? So if I ask the kids to read this first set of directions before I jump to the problems, we're going to use our manipulatives. So y'all are going to use the circular manipulatives, the fraction bar manipulatives. It doesn't matter which ones. If they all can have one grade. If not, definitely, partner it up. So they're going to build 3/8 and 2/8. How do you know which more is less? Well, one thing I'd ask them to tell me after they built them is, first of all, without the manipulatives, just look at the digits. What do we know about each? First of all, how do we know each of them are fractions? Let's start there. They both have numerators, and they both have denominators. Okay, what do numerators say? N sound. Know what you're looking for or talking about. We're talking about 3 out of 8 on one side and 2 out of 8 on the other. So let's say these together. 3/8, 2/8. What does D denominator say? Divided into. Yes, my whole amount is divided into 8. Yes, my whole amount is divided into 8. All right. How do we know which one is more or less? Okay, y'all look at the manipulatives. Which one has more? 3/8. Okay, so we're going to say right here, more. And let's use words. 3, and you're going to put a hyphen. 8, which is 8, EIGHT, HS, is more. And it says, how do you know? Well, I would love to write because I can see it with my own eyeballs. I would just say, I would just tell them that sometimes I don't actually write that stuff out when I'm doing it with the students. So I would just talk about it with them. How do you know? Well, we can see it, right? And if it were a pictorial model, and you might draw one, tell the kids they don't have to draw one because they have manipulatives unless they want to. First of all, we know our fractions have to be congruent. Same size, same shape. The fractional pieces have to be congruent. Same size, same shape. If you're talking about the same denominator, that's really easy. If you have 8 pieces and over here you have 3 of the 8 and over here you have 2, well, definitely 3 is more than 2 out of 8. And 2 dots are more than 1 dot. All right, I'd give them time, tell them I'm going to give you 2 minutes to build this. Put your pencils down or keep your hands still when you're done. All right, well, let's look at the fractions first. We know they're fractions because we have numerators. We nod our numerators and get down with these denominators. And what do we know the denominators say? Divided into. Yeah, my whole set is divided into 2. This whole set is divided into 10. Well, the denominators are different. So in this is a little more hard. It's easier when the denominators are the same. However, how do we say this fraction right here? 1/2. Let's write that. 1. How do y'all spell half? Good. HALF. 1/2. Well, halves are pretty simple. Because remember, when you get cut into half, hi-ya, you get cut into 2 pieces, right? Well, if I had a pie, I hate a pie with 10 because, yuck. This is why I tell kids to use rectangles. If I have a pie, or this time a cake, and I cut it in half, hi-ya, what do I know needs to be on each side to make 10? 5 and 5. So half of a 10 is 5/10. Well, we only have 1 out of 10. So you'd have 5, and then you'd have 5, right? But this is half here, half here. Well, we're talking about 1 out of 10 compared to, we're talking about 1 out of 10 compared to half. Halves are more. So 1/2 is greater. Let's use synonyms than just more. How do I know? This is one where I would put, well, I know 5 out of 10 is equal to half, because 5 is half of 10. So 5 out of 10 is half. So 1 out of 10 is definitely less. All right, fractional amounts. Give y'all a minute to build these. Now this is the most difficult of all. Not only are your denominators different, but neither one of these are halves, which is an easy fraction to understand. So let's talk a little bit about denominators. What do they stand for? Divided into. Okay, so if I have a fraction bar, let's say I have a piece, let's see, I don't know, let's say this is a crunch candy bar. First of all, my fractions need to be congruent, same size, same shape. What do I need to divide this fraction set into? Fifths. Why do I want to say fifth with a TH at the end? Yes, because this means parts, as in 5 parts, not 5 whole pieces. How many are we talking about? 3. 1, 2, 3. Over here, what do we want to divide it into? Fourths. And how many are we talking about? 3. Now here's something you need to realize. The more we divide our shapes into, do they get bigger or smaller? The more you divide something into, does it get bigger or smaller? Smaller. For example, I divide a pie in half. That's a denominator of 2. I divide my pie into thirds. Are the pieces bigger or smaller? Smaller. Now I'm going to go into fourths. Pieces bigger or smaller? Go into sixth. I think this would be a good way for them to understand what we're talking about. Eighths. Mine would be drawn a lot neater if I wasn't videoing. So fractions are opposite of whole numbers, because we know if I have 2 pencils, that's less than 4 pencils. And 8 pencils is more than 4 pencils, and 8 pieces is more than 2. But these are whole numbers, as in whole amounts, whole circles, 2 whole circles, 4 whole circles, 8 whole circles. Fractions are not whole amounts, they're parts. And the more your denominator is broken, the smaller and smaller they get. So when you know a denominator is larger than the other, we know these pieces are smaller. So 3 out of 5 are going to be smaller than 3 out of 4. So therefore the fifths is less, and 1 dot is less than 2. And notice that this is a simple comparison. You could have easily knocked out the symbols with the manipulatives, but good teaching requires discussion and thought and collaboration. So I think this would be a very powerful tool for them on this. All right, so down here we're going to use what they give us. So girls, read us above and below about Mrs. Jones. All right, boys, what are we looking for? A number sentence? Not true. Very good. Not. Your little puppy ears better be at full attention, because we are used to circling what's true. Now we're circling what is not true. Well, we're going to use these fraction bars. We're talking about a half. I'm going to lightly shade in mine. You can too. So y'all go ahead and lightly shade in half, or with your highlighters, go in and highlight half. Now right here, we're comparing a half to a what? 1/4. What symbol is this? How did you know that? That's right. It is greater than because 2 dots are greater than 1. So they're saying half, 2 dots are greater. So half is greater than 1/4. Is this true? That a half is... Okay, good. Let's circle it. You all went off the cliff if you circled it with me, and I would point that out. Did that the other day to, I don't know, I think 4th grade. Anyway, no. This is true, which makes it wrong, which is why it hurts our little heads. All right, I'm going to go to these halves since I already have halves. I'm right here. 2 dots are greater than 1, so this is greater than. They're saying 1/4 is greater than a half. Is 1/4 greater than this half? No. No, this is not true, which makes it the correct answer, which is why it hurts our head. And again, I jumped to this one because I already had a half and 1/4. So before I colored more stuff. Over here, girls or boys, read us about the model. Okay, what do we know? Why are there, how many triangles are there? 6. Oh, yeah, because D, denominator, says divided, my whole set is divided into 6. How many should we highlight? 4, correct. All right, what are our directions, girls? What should we summarize? We're writing a fraction representing part shaded. Oops, maybe I should have paid attention. Shade the model so that less than 4/6. Less. So we could have highlighted 1 out of 6 or 2 out of 6 or 3 out of 6, which I probably would have connected to a half, and any of those would have been less than 1/6. See, read, pay attention, Catherine. All right, I'm going to read this one. I want y'all to read the fractions as I come across them. Sometimes I do that when it's really large. So I read about Todd finishing 2/3, or Zach finishes 2/3, Todd finishes 2/4, blah, blah, blah. All right, class, what are we looking for? We're looking for a statement that is true about completed homework. All right, so I want truth. Could I use my manipulatives? I sure could. However, that's not going to be out on a test. So let's try some other strategies. First of all, look at your fractions. You have 2/3 and you have 2/4. What can you tell me about them is the same? Yep, the numerator. Over here, you're talking about 2 pieces out of 3. And over here, you're talking about 2 pieces out of 4. Well, let's think about what I know about D denominators. I'm going to bring you back over here. One of these is in thirds and one of these is in fourths. What do you know about the larger the denominator? Smaller the pieces. So over there, they're saying, one of them did 2/3, well, the other one did 2/4. Well, this would be half of the thirds right there. So 2 out of 3 is more than 2 out of 4 because thirds are larger. So I would definitely use my understanding, but then go back to these models if you drew them. So they're saying Todd, who did the 2/4, so I like to label Todd and Z. And we just all agreed that because thirds are bigger pieces, 2 out of 3 is more. Todd finished with greater. Todd's is not greater because Todd's pieces are smaller. Now that won't matter except that their numerators are the same. So again, if the numerator is the same, we're working off a denominator. Zach finished a smaller fraction. No, Zach's 2/3 is more. Todd finished a smaller fraction of homework. Yes, they both did 2, but 2 out of 3 is more than 2 out of 4 because numerators are the same, but denominators are different. So you'd have a half. Oh, good, that pen doesn't work. It's exactly helpful right now. Because you have half, and then you have half. This one is more than a half. So we could use manipulatives, except we need to start getting the kids to reason without them because they're not going to get to use them. A lot of them. All right, read about Cindy as a whole group. And stay together. Blah, blah, blah. All right, let's summarize. What are we looking for? A sentence that is true about cups of cherry juice and lime juice. Now, if they gave me models, you bet I'm going to use them. So Cindy uses 1/4 of cherry. So we're going to shade up to 1/4. And 2/4 of lime. It says as shown, who knows, it might have been shaded already and it just didn't copy over. But definitely if there are models, kids need to use the models. Now before we start, I'm going to ask y'all a question. How do they know that these measuring cups are in fourths? Besides that it says fourths. Like how do they know to write fourths and not sixths or thirds? Because D. There's that stupid pen again that didn't work. Because D, my whole cup is divided into 1, 2, 3, 4. My whole cup is divided into 1, 2, 3, 4. Just bringing back understanding. So what do we know? They're definitely not equal. These are not equal in size. No. 1/4. What is this symbol, everyone? Less than. That's right. 1 dot is less than 2. Is 1/4 less than 2? True. Bam. Moving on. All right, we got a model. Excellent. So she's comparing fractions of muffin eaten as shown. So these are how much have been eaten. All right, what are we looking for? We're looking for a conclusion that the chef makes about eaten muffins. Well, how many muffins of blueberry are eaten? 2 out of 2, 4, 6, 8. Kevin, why don't you go put stuff up? 4 out of 8. Cranberry. All right, so I know F is wrong immediate. Actually, I wouldn't say that. I would say so 2/8 of blueberry have been eaten, 4/8 of cranberry. So this is C, cranberry. And this is why it's powerful to go through stuff before them. Blueberry. I want y'all to look at your fractions below. And I want you to tell me, ooh, something's wrong here. I would say that the only one right is this one, and it's not right. Because we don't have 6 out of 8. Oh, Miss Pierce is a dummy. Sorry, I hate this. Sorry, in 4th grade, y'all, they do not do this to the kids, which is sad that they do it. So this is, all right, so we're talking about eaten, right? And they're wanting to compare how many were eaten. If they were eaten, would they be in the tray or would they be gone? They'd be gone, yeah, because you pull them out and then you rah, 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 rah. We actually eat them. So right here we've had 6 out of 8 eaten, 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 eaten. 2 out of 6 remain, but we don't care about remaining. We care about what was eaten. This one was pulled out and eaten, 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 eaten. Didn't change there. So saying that, G's out. First of all, I can see it's not equal, and so that one's out. So what symbol is this? I might call on a specific kid. How did you know? Yes, 2 dots are greater than 1. So they're saying 4/8 is greater. Is 4/8 more than 6/8? No, if you both are in 8s, 6 out of 8 is more than 4 out of 8. More customers preferred blueberry because 6/8 is, yes, greater. 2 dots are greater than 1. Yes, 6 gone is more than 4 out of 8 gone. And there's your answer using the models. Rulers. We need a sentence to correctly compare boys grown. I like this because it doesn't give them the fraction. Well, it does give them the fractions up here. So Ray had grown 7/8. Let's write 7/8 right here. 7/8. and Ed was 5/8. Let's show let's show it. I want y'all to jump along the bottom. Here's your whole set. Where's your whole set at? Your whole set is 0 to 1. That's a full set. That's a full inch, a whole inch. Let's jump spaces. 1, see what I mean? Let's do it. 1, let's count together. 2, 3, 4, 5, 6, 7, 8. How did they know to say 7? Because we only went 1, 2, 3, 4, 5, 6, 7 of the way. 7 spaces out of 8, 7/8. Ed's, let's find the whole set. 0 to 1, that's one whole number, one set. 1, 2, 3, 4, 5, 6, 7, 8. And we're talking about 1, 2, 3, 4, 5 of them. All right, so now that we kind of know what we're talking about, definitely see that they are not equivalent. I can see it. Here's how else I know, guys. If we're in eighths, eighths would be the same amounts, right? Same fraction. So 7 out of 8 is going to be more than 5 out of 8. What is this symbol on A? Less than. Yes, 1 dot is less. 7/8 is not less than 5. So it's got to be this. Oh, they're both greater than. Which one's right, y'all? Take a minute. All right, what do y'all think is right? D is correct. Because 2 dots are greater than 1. 7/8 is greater than 5. Okay, Russell compared fractions using the symbols. All of his statements are true except one. So we want a statement not true. Well, 3/8, 3/4. Are the denominators the same? No. But the numerators are, right? What do we know about D denominators? When you draw this out, are fourths or eighths larger? Larger pieces. Which one would have larger pieces, fourths or eighths? If they tell you the wrong answer, flip back. No, remember in fractions, the larger the division, if you're dividing between 4 friends or dividing between 6 or you're dividing by 8, you want to divide with 4 friends because the less friends there are to divide with, the more you get. The more you're dividing, the less and less and less you get. So 3 out of 8 is going to be less because 8s are smaller. This is fourth against fourth. Well, if you have 3 out of 4 versus 2 out of 4, what are 2 dots? Greater. Is 3 out of 4 greater than 2 out of 4? Yes, this is true. Ooh, and see? Because this one was not true, I didn't put my puppy dog ears on. Right here, 2, 6, they're the same fraction right here. Same division. Same amount of pieces. So 2 out of 6 would definitely be G greater than 1 out of 6. A third is less than a half. Yes, because thirds, the larger the denominator, smaller the pieces. The less the denominator, bigger the pieces. So 1 out of a bigger piece would definitely be greater than 1 out of smaller. All right. You know, girls, read this one. What are we looking for? We're drawing models to represent 2 fractions. What should we make sure of before if we decide to draw circles or rectangles? What do we know we have to do? Hopefully they say, or what, you know, that they need to be congruent. If they say equals, say, well, what's a better word? Can anyone think, or has anyone been listening to a word we've been saying that means same size, same shape? Again, even if you're, and this is when I point out, this is why I don't use models a lot that I draw, because I'm not Jesus. And I am not perfect at all. And when you're videoing, you sure as heck aren't perfect. What do we know about the fractional pieces within? They also have to be congruent. They have to be same size, same shape. I highly encourage kids to use rectangles unless they're for sure about how to divide a circle. Because circles aren't as easy unless you know. All right, well, how many of the thirds should we shade? 2. How many of the 6 should we highlight or whatever? 2. I would highly recommend shading on the same side. All right, now they want us to make a sentence. Sentences use punctuation marks in math. It's going to be these symbols. So we're going to say that 2/3 is greater. How do I know which one's greater? 2 dots. Yeah, 2 dots are greater than 1. 2/3 is more than 2/6. And lastly, this one. The baker bakes 3 identical cakes. Notice they're congruent, y'all. Same size, same shape. He cuts the first into 8. Yep, D. I'm divided into 8. D. I'm divided into 6. And D, my denominator, is divided into 8. The shaded parts represent what was eaten. That's fabulous that it's shaded because I don't see that. So based on these answers, looks like we're going to have 5/8, 7/8, and 5/6. Good thing I can use deductive reasoning. So 5 out of 6, 5 out of 8, 7 out of 8. All right. Is 5/6 equal to 5/8? Are these equivalent in what is shaded? No. First of all, 8s, D, if you're divided into 8s, these are smaller pieces. So 5 out of 8 smaller would be less than 5 out of 6, which would be bigger pieces. 5/8 is, what is the symbol? Greater, yet 2 dots are greater than 1. Does 5/8 have more than 7/8 shaded? No. Not only that, if they're both in 8s, 5 out of 8 is going to be less than 7 out of 8. And ask the kids to reason that too, I mean, at this point. 5/8 is 1 dot is less. 5/8 is less than 5/6. Is 5/8 less than 5/6 in shading? Yes, it is. If you know, and sometimes the models aren't always the easiest, but I tell the kids, well, look, it would kind of be like that section, so all this is shaded over there. Also, numerators are the same, right? So that goes back to here, 8s. If you're divided into 8, you're smaller pieces, right? If you're divided into 6, these pieces are larger. Now, this doesn't always work in 4th grade because their numerators are different. In 3rd, though, they're okay. So 8s are smaller, so 5 out of 8 would be less than 5 out of 6. So this is true. Write another fraction with a denominator of 6 less than 4/6. You know where I think that belongs? I think that belongs up here. That's because when Tori and I were making this, yeah, we accidentally cut apart some of the questions with the models. All right, but this is tomorrow's comparing fractions.